Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on October 6, 2025, just yesterday. Its big move is a first comprehensive deep dive into post-training for video large multimodal models, unifying supervised fine-tuning with chain of thought, reinforcement learning from verifiable objectives, and test time scaling. The paper is titled Video-LMM Post-Training, a deep dive into video reasoning with large multimodal models, and the implications for model training are quite significant. The survey maps roles and connections, tackles temporal and spatial grounding and long video efficiency, and spotlights open issues in reward design, scalability, and cost performance, while curating benchmarks and metrics. Also, the authors shared a GitHub repo. It's an updated awesome list for Video-LMM post-training. You'll find a clear README, sections on reinforced Video-LMMs, SFT for reasoning, test time scaling, and benchmarks, with links to papers, code, and datasets. There's a JSON catalog of entries plus simple update scripts and assets. While Figure 1 lays out the post-training roadmap, showing how video models progress through 3 pillars toward reliable reasoning. The left stream highlights supervised fine-tuning with chain of thought, which means the model practices writing intermediate steps to structure its logic. The center block focuses on reinforcement learning from verifiable objectives, so answers align with measurable signals. The right side introduces test time scaling, which allocates extra compute during inference for multipath reasoning and voting. Along the bottom, curated datasets and methods anchor each stage. Alright, Figure 2 tracks the research momentum, showing cumulative counts climbing as the community rallies around video reasoning. The red curve for total papers rises fastest, while the blue reinforcement learning and purple test time scaling subsets also accelerate, which signals consolidation around verifiable training and smarter inference. Test time scaling means spending extra computation during inference to sample multiple reasoning paths and vote. The word cloud emphasizes video, reasoning, and understanding, with temporal and multimodal terms close behind, acts as map time against cumulative count, so growth rate reflects community focus. So Figure 3 organizes the whole post-training landscape, showing how methods and datasets cluster into clear branches that practitioners can navigate. The diagram groups 4 streams: supervised fine-tuning, reinforcement learning, test time scaling, and benchmarks. Reward design highlights temporal intersection over union, which is a score for how well predicted time spans overlap the ground truth, plus spatial grounding signals. The rightmost branch consolidates evaluation suites, so progress can be measured consistently across tasks. Alright, Table 1 distills how leading video models actually train, so listeners can spot common recipes at a glance. The table shows many rows following a 2-stage path: chain of thought supervised fine-tuning, then group relative policy optimization reinforcement learning. Several systems use pure reinforcement learning, which signals confidence in verifiable rewards. Test time scaling is uneven across entries, because extra inference compute raises accuracy, but also latency and cost. Alright, 2 takeaways stand out. Supervised fine-tuning with chain of thought is a strong cold start, but reinforcement learning with verifiable rewards drives robust video reasoning, and test time scaling improves fidelity when its compute budget is reported clearly. The broader implication is a unified recipe and shared benchmarks that make progress reproducible. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.